All right. You are welcome to today's class. I welcome every one of us once again. Today's class will be diving into hydrocarbon. Okay. So before we proceed, I would like you to subscribe, like, comment, and share. All right. Thank you very much. So let's proceed. I want this class to be very interactive. I want this class to be interactive. So I want you to drop your view, your questions in the comments. Okay, if you have any questions, drop it on the comments. Okay, so let's proceed. I'll quickly show us the outline for today's lecture. The outline here before us are the outline. We have that is in this hydrocarbons tutorial. Origin of hydrocarbons. Where do we get this hydrocarbon from? What are hydrocarbons? These hydrocarbons we are talking about, what are they made of? What are those components that made up of hydrocarbon? Classification of hydrocarbons, general formula for what? Hydrocarbons. I found that most students found this difficult to memorize the formula for the hydrocarbons, such as alkane, alkenes, alkynes, cycloalkanes, and so on like that. So although cycloalkanes is not usually common like that, but in this video I will make it very simple, and I will show you the tricks, the easy way you can memorize this formula without stressing yourself. Okay, we'll be looking at the physical properties of hydrocarbons, the chemical properties of hydrocarbons, uses of hydrocarbons, and we solve questions. Now, I would like you to take note of something. That do you know that the fuel in your car or your cooking gas, do you know that they are made up of hydrocarbons? Do you know that petrol, diesels, kerosenes, they are made up of just ordinary hydrocarbons? What is these hydrocarbons that we are talking about? Hydrocarbons, let me speak on the origin first, are being derived from the decomposition of dead decays of plants and animals. You know, if plants and animals, if plant and animal die for thousands of years, millions of years, when they decay, there are some organisms that will break down this decay of plants and animal and convert them. I don't want to speak much on the origin. I don't want to speak much. So they convert them to hydrocarbon, that is organic compound. Okay. So what is hydrocarbon? Hydrocarbons are chemicals gotten from where? From hydrogen and carbon. From the word hydrocarbon, that is, it combines hydrogen and carbon together. These are chemicals that we get from where? From hydrogen and carbon. If you look at your petrol, it's a chemical. It's made up of hydrogen and carbon. It's under hydrocarbon. If you look at kerosene, it's made up of hydrocarbons. It is still under hydrocarbons. If you look at your cooking gas, that is the cooking gas you normally use to cook your food, it's made up of hydrocarbons, which we call the butane. Okay? So in this video, we break this hydrocarbon, we break it down to the best of our knowledge. So let's quickly look at the classification. I've explained that hydrocarbons, they are chemicals gotten from hydrogen and carbon, just hydrogen and carbon, as the names implies. Hydrocarbon, hydrogen and carbon. Okay, so let's quickly look at the classification of these hydrocarbons. Hydrocarbons are classified based on two different methods. Two different ways. Now, this you are looking here, this one you are seeing here is classified based on structure. Another way we can classify hydrocarbon is based on bonds. But when we get here, I will explain better. Now, these hydrocarbons is classified into two, the aliphatic and the aromatic. Aromatic, such as benzenes, is also made up of hydrogen and carbon. It's a combination of just hydrogen and carbon. Although, let me come back that organic chemistry is classified into two. Organic chemistry, not hydrocarbon. Hydrocarbon is under organic chemistry. Okay. So under the classification of hydrocarbon, under the classification of organic chemistry, we have the hydrocarbons and the non-hydrocarbons. But in this class, we'll be looking at the hydrocarbon aspect. So as I was saying, that aromatics such as benzenes is also made up of hydrocarbon, just carbon and hydrogen only. Now, looking at aromatic, aliphatic. Aliphatic is different from benzenes. Aliphatic is classified into two. We have the acyclic and the cyclic. What is this acyclic? Acyclic are those aromatic that are in straight chain or branch. They are either straight or branch. Okay. Why cyclic? They are in form of circle. They are in form of circle. They are not straight, but they are in form of circle. I will show us some examples here in this video. So, aliphatic, yeah, we said it's divided into two, the acyclic and the cyclic. The acyclic is divided into three: the alkanes, the alkenes, and the what? And the alkynes. Why this cyclic? Cyclic is just like the cyclo form of what? Acyclic. Okay, it's just like the cyclo form of acyclic. And now, if you look at alkane here, you will see that we have alkane. Now, look here, we have alkane here. What is the cyclo form of alkane? Is called what? Cycloalkane. Okay, we have alkenes here. What is the cyclo form of alkenes? It is called what? Cycloalkenes. Cycloalkanes is not usually common. It's not usually common. Okay, so we have alkanes. We have the cyclo form of alkane to be what? Cycloalkanes. We have alkenes, and its cyclo form is called cycloalkenes. Okay, and we have alkynes as well. Okay, quickly let's proceed. Let's proceed. Now, I said something earlier that acyclic, they are either in straight chain, or what? Or branch. Now, if you look at examples of acyclic, you know, I said acyclic is divided into three: alkanes, alkenes, and alkynes. Now, the examples you are seeing here, they are examples of just only alkanes. Just only alkanes. Now, you can see here that we have all the carbons here. All the carbons here, they are in straight chain. Why? You can see that this one is what? Is one of the carbon branched to the other side here, just as you can see. Now, the same thing applicable to this. You see that all the carbons are in straight chain. As I've said that, acyclic, they are either in straight chain or what? Or branch, but they are not close. That is what differentiates acyclic and cyclic. Cyclic are closed, while acyclic are not close, but they can be branched. Okay, so you can see that there's one carbon that branched to this point, and there's another carbon that branched here. Okay, though I'm not explaining names for now. I will prepare videos for names. All these ones you are seeing here, all these ones is just the isomers. It's just the isomers of pentane. So, but I'm not explaining isomerism here. I'm not explaining that for now. I will prepare video for isomerism later. Okay, so let's proceed. Now, you can see the cyclo form of alkane. I said earlier that we have alkanes and we have its cyclo form. Now you can see the cyclo form of alkane. But why do you know that it is alkanes? Alkanes, they usually have single bond. Now, if you look at this diagram you are seeing here, you see that they all have what? Single bond. You can see single bond there. You can see that it's single bond. You will see that they always have single bond. What is here is the same thing as what is here, as you can see here. So they always have single bond. That's how you can identify that it is alkanes. But if you check, you see that they are still close. They are close, right? So as I've said that these are the cyclo form of what? Cyclo form of what? Alkanes. All right, let's proceed. Now you can see for alkenes. Alkenes now. This is an example of alkenes. Don't worry, I will show us all this, how you can like get the formula for all these alkenes, alkanes, cycloalkanes, and cycloalkenes. Okay, I will show us the formula. I will make it very, very simple. So this is alkenes. You can see that the first one here is in what? Is a straight chain, while the other one is what? Branch. To tell you that it is under acyclic. Okay, so let's look at the cyclic form of alkenes. Now you can see the cyclic form of alkenes. They are close. They are close. Can you see? But what differentiates them is that, as I've explained, what differentiates them is alkenes are single bond. Alkenes, we have what? Double bond. You can see that there's double bond here. You can see here, there's double bond. You can see that there's double bond to tell you that it is alkenes. You can see that there's double bond. So that you can see that there's double bond there. So that is what differentiates alkenes from what? Alkanes. Alkane has single bond. Alkenes has double bond. While alkynes has what? Triple what? Bond. All right. So move to alkyne now. You can see alkyne. Alkyne has what? You can see the straight chain of alkyne. You can see it. It has triple bond, as I've said earlier. That is what differentiates alkynes from where? From alkanes and alkenes. As I've said, alkane has single bond, alkenes has double bond, while alkynes has what? Triple bond. All this I'm showing you, I'm just showing you as an example. That is not where I'm going to. All this one, they deal with isomerisms, but I'm not dealing with isomerism now. So don't be scared. But I will soon focus on our main point. I'm just showing you for you to identify the difference between alkanes, alkenes, alkynes, cycloalkanes, and what? And cycloalkenes. All right, now this is what I'm going to. This is what I'm going to. I think that was the mistake here. But I will explain it. I will explain what is going on there. I will explain what is going on. Now, the formula for alkanes is Cn. Where there is box here is N. Is N. Is N, not box. Is N. Where there is box, just take note that is what? Is N. Okay? So, the formula for alkanes, this is where I want to show you the trick now. How you can easily grab this, all these 5 things you are looking at here, their formula. Now, there is N there. It is N. Where you are seeing box there, it is N. It is N. So, what you only take notes here, do you know it? It's just know the formula for alkanes alone. Just know the formula for alkanes to be CnH2n plus 2. Now, I will derive the rest from the formula of what? Of alkanes. I will repeat it again. Just take note of the formula for alkanes alone. You can bring out your pen, write all these things down. They are very compulsory. So take note of the formula for alkanes alone to be CnH2n plus 2. So now I want to derive the formula of alkenes from alkanes. I want to derive the formula for alkynes from alkanes. I want to derive the formula for cycloalkanes from alkanes. And now I want to derive the formula for cycloalkenes from where? From alkanes. Okay? Now what will you do? For alkanes, alkynes, as I've said, take note of the formula for alkanes. So to get the formula for alkenes, without you stressing yourself, once you know the formula for alkanes, you know what? Just do this thing. Just subtract 2 from the formula of alkanes. You know, we have plus 2 here. We have plus 2 here. We have plus 2 here. So when you subtract 2 from it, you know, plus 2 minus 2, it will cancel. We'll be left with what? CnH2n. So that is the formula for what? That is the formula for alkanes. That is the formula for alkanes. You can see that it's very, very simple. Now, to get for alkynes, you know, when you are trying to get the formula for alkenes, you subtracted 2, right? But now to get for alkynes, you will not subtract 2. You will then subtract 4, not 2. You subtract 4 from the formula of what? Alkanes. You know, alkanes, you know, is CnH2n plus 2, right? So if you subtract 4 from 2, that is plus 2 minus 4. This is a simple mathematics. Plus 2 minus 4. It will give us what? Minus 2. Minus 2. So the formula for alkynes is what? CnH2n minus 2. As I've said that, where there is box here, it represented N. N, where there is box, take note, it represented N. So to get the formula for alkynes, it will then be what? CnH2n minus 2. You can see that it's very simple. Let me repeat that again. The only thing I say you should know is formula for alkanes. What follow alkane is alkenes. So to get the formula for alkenes, just subtract 2 from the formula of what? Alkanes. And to get the formula for alkyne, just subtract 4 from alkanes. You will get the formula for what? Alkynes. What about cycloalkane? Cycloalkanes is the same method you still apply. You know, this is cyclo of what? Alkanes. So it is the cyclo form of this alkanes here. You can see here. It's just the cyclo form of this alkanes. So what will you do too? Now we are dealing with the cyclo form again. Now come to alkane again. Subtract 2. When you subtract 2, it will give you what? CnH2n. CnH2n. So that just it. And to get it for cycloalkenes, so come for where there is alkenes here. You know the formula of alkenes here. So these are alkenes. So just subtract 2 from the formula of alkenes. You know the formula of alkenes here is what? CnH2n, right? So just subtract 2 again. It will be left with what? You'll be left with CnH2n minus 2. So that is how we arrive at the formula for cycloalkenes. This is just the trick on how you can easily get the formula for all these compounds you are looking at. I came across a question some years ago that it should be, I don't know whether it's jump, that they said the question is just that maybe alkenes have the same formula with what? Now, alkenes have the same formula with what? With cycloalkanes. That is the correct answer. Why alkynes have the same formula with what? Cycloalkenes. Alkynes have the same formula with what? Cycloalkenes. So that is how we arrive at that formula. If you have any question, you can drop it on the comment here. I will reply your question. Now, let's look at the properties of this hydrocarbon we are talking about. Now, let me use of alkane as an example. Do you know when you drill crude oil and you take this crude oil to refinery, you separate this crude oil into different components? We have crude oil and natural gas. We have crude oil and natural gas. So if you take this to the refinery, natural gas now, because the first 4 members, or let me just majorly the first 4 members of alkanes are from natural gas. So if you separate it, you will see that the first one is methane, ethane, propane, butane. Those 4 are gas. Now, if you look at your cooking gas is butane. Is it not a gas? It's a gas. It's within the range of carbon 1 to carbon 4. Your butane is C4H10. I will show you here how you can get it. I will show you. Don't be scared. So it's C4H10. That's the formula of your butane, the one you normally use to cook your food at home. So that's for that. It's gas. Why? If you are going down the alkane, if you are going down to the alkane group, you will see that you will get to, after you have getting your cooking gas, you get your petrol. You know, petrol is now liquid, right? As you are going down, your boiling point is increasing. Why? The more the viscosity. Okay. So as you are also going down, you will get to a point where you reach diesel. You know, your diesel is more thicker than your petrol and your cooking gas. So as you are going down, you will get to a point that you will start seeing solid. At the beginning, you start seeing gas. You know, your petrol is majorly C8 H18. So your petrol, is it not a liquid? It's a liquid. So your kerosene, is it not a liquid? It's a liquid. As you are going down, you know, we started from gas, next to liquid. Next one, as you're also going down, you will get to a point where you start seeing solid. So as you're also going down, their boiling point increases, and the more denser it is, they are denser than water. If you notice, if you mix petrol or kerosene with water, you notice that kerosene will flow on top of the water, right? To show that kerosene or hydrocarbons or organic compounds, they are usually denser than what? They are usually denser than water. And they are also not what? They are not soluble in water. Take note. They are not soluble in water. If you talk of the solubility, they are not soluble in water. And they are highly flammable. They can easily burn. If you notice all this tanker that is carrying petrol, they usually write something at the back, highly flammable. So they can easily burn at any time. So let's quickly proceed to the chemical properties. Now, you see, all these hydrocarbons we have been talking about, be you alkane, alkenes, alkynes, or benzene, as far they are hydrocarbon, take note, all hydrocarbons, when they burn, they will give these two methods, these two formula. They will give these two products. I can see someone, bro, can you make a video on other subjects like economics and business? Okay. Well, this let me just say I'm a science student. I don't really know much on business, this thing, but I will reply you for that. I will reply you, and we think of what we can do to that. Okay, so I'm very sorry. All right, so if you have questions, you can drop it as I'm speaking now. Like the video, share the video with your friends. All right, now talking of combustion, I just want to show you something here. Have you ever noticed that if you burn, if you burn or if you see a car moving, especially a new car or a new motorcycle, you notice that, or let me just use this as an example. If you are burning a wood, if the wood is burning well, you will not see any smoke. Will you see any dark smoke coming out? No. But if the wood does not burn well, you will start seeing black smokes. Is that true? So the same thing applicable to all these petrol, diesel, all these hydrocarbons. We have two products. It's either they burn well or they don't burn well. If they burn well, this is what it will give us. It will give us CO2 and water. For example, if your petrol burn with oxygen, it will give you CO2 and water. That is complete combustion. If it burns completely, it will give you CO2 and water. If it does not burn completely, it will give you CO and water. That CO2 I mentioned earlier is what? Carbon dioxide, or often called carbon dioxide. Why? CO. Well, some people call it carbon monoxide or carbon dioxide. So if it does not burn completely, it will give you CO plus water. So if in a case whereby you see a motor or a motorcycle moving and you start seeing black smokes coming out, you will not go near it, because inside that smoke, it is dangerous when hydrocarbon does not burn completely. Take note, it is dangerous when hydrocarbon does not burn what? Completely, because there will be presence of a gas called what? CO. Yes, carbon monoxide. This carbon monoxide is very dangerous to the red blood cell. If you inhale this gas, it will attach to the hemoglobin and it will affect you. So I don't want to go deep into that, but it's very, very dangerous. So combustion, we have complete combustion and incomplete what? Combustion. Okay? So take note of that. All right, let's quickly move to the next one. All right, this is the formula we use to balance a situation whereby hydrocarbon react with oxygen. You see, this formula, we will not make use of it here now. We still make use of this formula. I just want us to leave this side. Let's proceed. We come back to use this formula. You remember? Wow. So we have started looking at questions now. Look at this question. Hey, there's something I didn't mention, but I just spoke briefly on it. That hydrocarbons are classified. Hydrocarbons, we can classify them into two types. The one I showed you at the beginning of this video is the structure. The structural way of classifying hydrocarbon. Now, we can also classify them in terms of bond. That is, we can classify them in terms of saturated and unsaturated hydrocarbon. You see, the one that has a single bond, which is alkane, it is only alkane that has single bond. So alkane is called saturated. Why? The one that have 2 or 3 bonds, that one is called unsaturated. Take note of that. Alkane is the only saturated we have. And you know alkane has members, right? Why? Alkenes, alkynes, they are unsaturated. But what about cycloalkane? Cycloalkane also has, we have alkane and it's cycloalkane also has single bond. So the two of them are saturated. Why? Alkenes, alkynes, cycloalkenes, they are unsaturated. Take note of that. So let's look at this question. It said, hexane, this is the formula for hexane, and benzene can both undergo what? Now, you see, saturated hydrocarbons, such as alkane and cycloalkanes, they undergo substitution reaction. What? Substitution reaction. Why unsaturated? Benzene is also unsaturated. But benzene is different. I will tell you the reason. Alkenes, cycloalkenes, and alkenes, alkynes, cycloalkenes, and cycloalkynes, they are unsaturated. And they undergo addition reaction. But benzene, aromatic, is an aromatic. It's different. It undergo both addition reaction and substitution reaction. Now, I want someone to ask me why in the comments. Or why do you think that benzene undergo both? Benzene undergo both substitution reaction and addition reaction. But my question is, which one does benzene prefer out of the two of them? It's an exam question, so I've come across this kind of questions. Does benzene prefer addition reaction? Because I said benzene is the only one that undergo addition and substitution reaction. Why the alkanes and cycloalkanes undergo substitution reaction alone? Alkenes, alkynes, cycloalkenes, and cycloalkynes, they undergo addition reaction. But benzene undergo both of them. Benzene prefer one to the other. Which one does benzene prefer? Drop it on the comments. Which one does he prefer? Drop it now. Drop it. I will come back to that. If you are right, I will tell you are right. Drop it on the comment. Which one does benzene prefer? And why does he prefer it? Someone say maybe substitution reaction because it is saturated. No, benzene is not saturated. Let me reply to this person. Benzene is not saturated. It's unsaturated. I said saturated hydrocarbon, they have a single bond. Alkanes has a single bond. I showed the picture earlier, although you still come across it. So it has a single bond. Why cycloalkane too, the cyclo form of alkanes has a single bond. So both of them are saturated. Why alkenes and its the cyclo of alkenes is what? Cycloalkenes. Alkynes, what is the cyclo form of alkynes? Cycloalkynes. Those ones and benzenes, they have 2 or more bonds. So they are referred to as unsaturated. So that is not the reason why benzene prefer substitution reaction. I need more comments. Drop your comments if you know it. Why does benzene prefer substitution reaction rather than addition reaction? Probably after 10 minutes, I will tell you the answer if nobody is dropping. But I like this way this person is trying. You can try, drop something there. All right, so let's answer this question. Let's answer. Now talk of decolorize. Let me check the question again. They say, okay, now option D says decolorize bromine water. No, it is only unsaturated, such as alkanes, those ones are the ones that can decolorize bromine water. Those saturated, they can't decolorize bromine water. Do you understand? So that one is wrong. It's not correct. Let's proceed. That one is not correct. Now you can see here that saturated hydrocarbons are those hydrocarbons that have single bonds between the carbons, such as alkanes. They have within the carbons, they have single bond between carbon to carbon. You see more example here. So they are less reactive. Okay, let's quickly go to the next one. So if I substitute, and this is the formula I've explained that earlier. Now you can see the example of an alkane here. You can see the example that, as I've said, that they have single bond in between the carbon to carbon. You can see them. You can see them here. You can see that they have single bond in between the carbons. You can see, but that's not where I'm going to. This one, all these, they are just an explanation to. They are just an explanation to what we have said. So let's quickly proceed. Unsaturated hydrocarbons are hydrocarbons that contain at least double or triple bond. As I've said, they contain at least double or triple bond. Okay. So types of unsaturated hydrocarbon, I've explained this earlier. That we have alkenes, we have cycloform of alkenes, which is cycloalkenes. We have alkynes, cycloform of alkynes, which is benzene prefers substitution over addition because substitution preserves its aromatic stability. In fact, God bless you. It's 100% correct. 100% correct. Wow, that is why benzene prefer substitution reaction, because it does not affect its rings. It does not affect its rings. That's very good. God bless you. You are active. Thank you for that. You are correct. Okay, so drop your question. This is for everybody. Let's interact. All right, these alkenes, double bond. Yes, I've explained this one at the beginning. Alkynes. This is just an explanation to that if you are substituting the value of n equals to 2 into the formula of alkynes. I've explained all these ones at the beginning. So test with bromine. Okay, notes both substitutions and reaction. Okay, benzene undergo both substitutions, reaction, and addition reaction. I've explained this. Okay, let's proceed. Option B is correct. Why is option B correct? Because if you look at the question, let me quickly show you the question. If you look at the question, let me quickly show you the question. Now, addition reaction, both of them does not undergo addition reaction because alkane is under it's under, what's it called? It's under acyclic. So alkane has a single bond. It does not undergo addition reaction. Alkane undergoes substitution reaction only. So that option is wrong. Option C is also wrong. Elimination reaction. No. Option D is the correct answer. Alkanes undergo substitution reaction. Why benzene undergo both of them? Both of them. Okay, let's move on to the next question. Now look at this question. Which of the following is unsaturated? When we talk of unsaturated, remember earlier that I said alkanes and cycloalkanes, they are saturated. So you know what end with alkanes? What end with alkane is what? A-N-E, right? A-N-E. So if you look at that first one, that option A is azane, is from alkanes. Benzene, is it from alkanes? No, benzene is not from alkanes. So benzene is unsaturated. Now I mentioned earlier, look at this one, 2-methyl pentane. What ended here? What's the last? Let me show you something here. Let me show you something here. What is this? What is this? This pentane, right? A-N-E. So that one is the cycloform of alkanes. And you can see for azane as well. You can see for cyclohexane, you can see that what ended is A-N-E. So they are under what's it called? They are under aliphatic. Oh, sorry, they are still under. They both have single bond, all of them, except benzene. So benzene has double bond, so it is therefore unsaturated. Unsaturated. So the correct answer there is option B. Option B is the correct answer. Okay, let me quickly. Yeah, let's move to the next question. Now, looking at this, aromatic compound is. Don't forget that I said benzene undergo both addition and substitution reaction, right? So you know the formula of benzene to be C6H6. C6H6. So what if you look at this, they somehow twist this question. You notice that the carbon and the hydrogen for benzene, they are the same. The carbon is 6, while the hydrogen is 6. But if you look at option A, C6, H13, that one is automatically wrong. If you look at option B, C6H is automatically wrong because the carbon and the hydrogen, they are almost the same. Look at option D is wrong. Option C now, you notice that it's very close. You know, I said in benzene, the carbon and the hydrogen, they are the same. C6H6. Now, what happened here is that there's something we call substitution reaction at benzene or that go. So when chlorine reacts with benzene, chlorine molecule Cl2, so it will, one hydrogen will have to leave benzene, one chlorine will have to go there. So that is why you see that the hydrogen of benzene, instead of it to be 5, it will reduce by what? By 1. Sorry, instead of the hydrogen of benzene to be 6, it reduced by 1, which is 5. And what replace it? Chlorine replace it immediately. So option C is the correct answer to this. Option C. Wow, this is another question. The following are hydrocarbons except. Now, when we talk about hydrocarbons, as I've said, it only contains hydrogen and carbons. Look at the correct answer. This one is wrong. Ethanol, because ethanol is C2H5OH. Oxygen has been added to it. Oxygen is not hydrocarbon. When you talk about hydrocarbons, it only contains hydrogen and carbon only. Hydrogen and carbon only. Yeah, you are right. You are right. This is another. Yeah, I can see your comments. You are right. This person. So it only contains hydrogen and carbon only. That is hydrocarbon. So ethane is a family of alkane. This hydrocarbon. Ethene is a family of alkenes. Alkenes, yeah, it's an hydrocarbon. Ethane is a family of alkyne, so it's an hydrocarbon. But ethanol, C2H5OH, it has oxygen. It's not hydrocarbon because of that oxygen that is there. So it's not an hydrocarbon. This is another one now. An unsaturated compound is. Don't forget that unsaturated. You look at all these words written here, all these options given here. Anyone that ended with the last 3 letters of alkanes, they are always saturated. Anyone that ended with last 3 letters of alkanes, they are always saturated. So you can see the option A ended with what? Option A ended with ANE. Is from alkanes. Okay, it's from alkane. That is cycloform of alkanes, right? Cycloform of alkanes. So that one is saturated. Benzene is unsaturated. We have mentioned this several times. 2-chloropentane, they are all this one. They are just the branching of alkanes. You understand? So it ended with ANE. Is from alkane. This thing. So it's still is saturated. And option D2 is saturated. But the last one, the one that is not saturated, that is unsaturated, is benzene. So I've mentioned this several times. If you were present at the beginning of this video, the laboratory preparation of ethynes involves the action of water on. Now, this ethyne, we can also prepare it in the laboratory when you dissolve calcium carbide. You know, we have calcium carbide. Calcium combined with carbide. If you dissolve it in where will you dissolve it? If you dissolve it in water, if you dissolve this calcium carbide in water, the calcium will have to leave away. Hydrogen and carbon will come together. I should have shown you the reaction. I should have shown you the reaction. Okay, so if you dissolve it in calcium carbide, that is, if you dissolve water in calcium carbide, that is how we prepare ethyne in the laboratory to give you ethyne. Okay, it will give you ethyne. That's for that. Not sand. Sand is wrong. Sand is wrong. Let's quickly look at this. The main constituent of petrol. You know, I've mentioned this. Do you remember? I said petrol has a formula of what? Petrol has a formula of. Wow, this person is trying. No, he's trying. Wow, that is very good. Edema, you are trying. That's very good. Okay, so if you see the main constituent of petrol is what? I said petrol have a formula of what? C8H18. But what do you notice there is that it's only C and H. That is carbon and what? Hydrogen. Carbon and hydrogen. So it's what? Hydrocarbons. This is option B. Ethanoic, it has oxygen. Ethanol, all those ones. No, they are wrong. The correct answer there is option B. Hydrocarbons. That's just it. The petrol you are using is just hydrocarbon. Mixture is the combination of Hydrogen and carbon. That is just it. Okay. Why is carbon often deposited in the exhausted pipe of a car? I've explained this when I was explaining the chemical properties of hydrocarbons. It resulted, you see black smokes, and I told you that the black smokes resulted as a result of what? Incomplete combustion. It was then I make use of wood as an example, that if you burn your wood, if the wood is burning completely, you don't see anything like black smokes. But if the wood, I'm seeing a question, sir. What is chemical formula of petrol? Yeah, petrol is from alkane. The formula of alkane is CnH2n plus 2. Okay, so if you put any to be equals to 1, you have CH4, which is methane. If your N is equals to 2, we have C2H2 times 2. That will give you 4 plus 2. That will be what? C2H what? H6. That is ethane. If you have your N to be equals to 3, like that. But if your N is equals to 8, that will give you C8 H what? You have H2 times N, right? That will be H2 times 8 plus 2. 2 times 8 will give you what? 16 plus 2. That will be 18. So that is C8H18. So that is the formula for alkane. That is the formula for petrol, because petrol is under alkane. Do you understand? Let me know if you understand it. Okay? So that's for that. Let's look at this. Yeah, I've explained that if you are burning wood, if the wood is burning completely, you will not see anything smoke. You see anything like black smoke? No, because it is burning completely. But if your wood is just burning anyhow, those that are using wood to cook, ordinary this wood. So you notice that if it does not burn completely, you start seeing like smoke. The same thing applicable to petrol. If it does not burn completely, you start seeing like all those black carbon, this thing, smokes, black this thing. You start seeing it. It's because it is incomplete combustion of what? Petrol. That is the correct answer. Incomplete combustion of petrol. That is for that. All right. More petrol is obtained from long chain hydrocarbons by the process known as. These are another questions. Petrol has the same formula as octane. Yeah, petrol is also called octane. God bless you. Yeah, petrol is also called octane. That is the name of, in terms of hydrocarbon. Why naming them? Pentane. What is it called? Methane, ethane, propane, like that. If you have C8, H18, that is octane. So it's also called petrol. Yeah, petrol. You are correct. Yeah, that is petrol. So more petrol are obtained from long chain hydrocarbons by the process known as what? Cracking. Let me ask you a question. Have you ever noticed why we crack all this oil? If you look at petrol and you look at diesel, which one is more demandable? Which one are they using mostly? You notice that they use petrol more than diesel. You understand? They use petrol more than diesel. So they crack all those heavy, like such as diesel. When they crack it, when they try to break it down, they will get petrol from it. They get petrol from it just because petrol is more demandable. People are using petrol more than diesel. And if you look at your cooking gas compared with diesel, how many people that are using diesel? And you look at your cooking gas, almost every house in the whole Nigeria or in every countries are using cooking gas, such as butane and propane. So if you crack every heavy hydrocarbon, such as diesel, those ones that are very heavy, thick, if you crack them, break them down, you will see light hydrocarbons such as petrol, such as your cooking gas, propane, and so on. Thank you, sir, for the clarification. Thank God, sir. Good evening, sir, everyone. My network is terrible. Oh, no problem. You can join us. You can. We still have more questions to answer here, although we soon round up. That is for that. So the correct answer there is cracking. It's cracking. So don't forget the reason why we crack now is because we crack to get to get more demandable products. Okay. So let's proceed. All right. Cracking. Now, can you tell me the difference between this pyrolysis and cracking? Can you tell me the difference? Tell me the difference in the comments. Now, you can see when you crack diesel, you can see diesel there. No, on some textbook, they use diesel, the formula for diesel as C12 H26. Okay, so that is for textbook, because all these things, they are usually range, because all these petroleum products, they have better quality than each other. Okay, so if you crack diesel now, look at it, you can see that we form what? Petrol there. Propane, the combination of propane and butane are what make up of your cooking gas. But the reason why we normally say butane is because 90% of it is from butane. 90% of it is from butane. So if you crack those heavy one, that's why you can see you get those lighter one that are more demandable. That is for that. But pyrolysis, tell me the difference between this pyrolysis and cracking. They are very close, very, very, very close. Tell me the difference in the comments. Tell me. Catalytic hydrogenation of alkenes produce that. All these things I'm showing, sincerely speaking, they are likely questions that will come out in your exams. Be you any exams you are writing, these are likely questions that usually come out in hydrocarbons. So don't play with it. Take note of all these things. Write them. Take note of them. Okay. So catalytic hydrogenation of alkenes produce what is there? Don't mind that grammar there. Hydrogenation there means adding hydrogen from the word hydrogen. That hydrogenation you are seeing here, this hydrogenation means adding what? Hydrogen. Hydrogen. When you if you notice something, go and check this or try this. You notice that I said for you to get the formula for all these alkenes formula, you subtracted 2, right? Which tells you that hydrogen is 2, that is more than alkenes with just 2 hydrogen. You understand? So if you add hydrogen to alkenes, it will give you what? Alkenes. It will give you alkenes. If you add hydrogen to alkenes, it will give you what? Alkenes. That is just it. That's just it. But there's a question I want to show you. What about benzene or alkynes? They can twist a question. They usually come out. If they say uncontrollable hydrogenation of ethyne. Uncontrollable hydrogenation of ethyne. They normally use that thing. Why 30 questions? Uncontrollable hydrogenation of ethynes. What would that give us? Let me erase this. Okay, so I've answered that part. Which are the following? I will still come back to that when you are dealing with uncontrollable hydrogenation. Now, which of the following statements is true about alkanes? Okay, option A says alkanes are liquid. Well, some of the alkanes are liquid, but not all. Your cooking gas, is it liquid? Your cooking gas is not a liquid. It's not a liquid, so it's not all. That one is not 100% correct. So option B says their general molecular formula is CnH2n. Is that the general molecular formula of alkanes? No, that is wrong. I mentioned this at the beginning of this video. The general formula for alkanes is what? For this one, the answer is A. No. If it is this particular questions, which of the following statement is true about alkanes, is not correct. But you try. God bless you. You try. I like your motivate. You are motivating me. Don't worry. I like your this thing. So let's proceed. The general molecular formula is that one is wrong. The general molecular formula for alkanes, I'll show you the trick. I've already showed you at the beginning of this video. Is CnH2n plus 2. That one is wrong. Option A is wrong. Option B is wrong. So let's look at option C. Hydrocarbons. Alkanes are they hydrocarbons? Yes. I mentioned that alkanes are always hydrocarbon. They are very reactive. Option B. No, they are not reactive. Let me tell you something here. Alkanes are not reactive. Why? Because they are completely filled. Carbon. Carbon inside alkane. If you notice, the atomic number of carbon is 6. Why the valency is what? Is 4. So carbon need like 4 other electrons to join carbon to make carbon stable. You understand now? So alkane, they are stable. They are just like group 8 elements. Group 8 elements, they are very stable. They are not reactive. You can call it group 8 element or group 0 element in the periodic table. So they are not reactive. So likewise, alkanes are not reactive. They are not reactive. But alkynes, those ones, they are very reactive. They are reactive. Okay, take note of that. So alkanes are always hydrocarbon. We have mentioned that, and that is correct. So let's proceed to the next question. We almost round up. Okay, we're almost writing up. Yeah, look at this question now. I made mention of something earlier at the beginning of this video that if you burn any hydrocarbons, as far as it is combination of hydrogen and carbon, if you burn them with oxygen, like methane now, CH4, methane, we have carbon and hydrogen, they are burning with oxygen. It will always give you either CO2 plus water. If you give it CO2 plus water, if it's burned completely, for example, if your kerosene burn with oxygen completely, it will give you CO2 plus water. If your petrol burn with air completely, that is, they can say burn with air or burn with oxygen, it's still the same. It will give you CO2 plus water. If your cooking gas burn completely, it will give you CO2 plus water. So this one is complete combustion. If it is incomplete, it will give you CO plus water. Now look at this question. Look at the way they just twist this question. What amount of oxygen will be required for the complete combustion of 5 mole of methane? Let me show you something here. Look at this question. We have 1 mole here. This is the same thing as 1 mole at the beginning here. It's the same thing as 1 mole. If 1 mole of methane combined with, well, how many mole of oxygen does it combine with here? Is 2 moles of what? Oxygen. 1 mole of methane will join 2 mole of oxygen to give you the product. Now we are now looking at 5 mole of methane. How many mole of oxygen will you combine? If 1 mole of methane combined with 2 moles of oxygen, so if 2 moles of methane now come, it will now combine with how many moles of oxygen? 4. If 3 moles of methane come, it will combine with 6 moles of oxygen. If 4 moles of methane are there, it will combine with what? 8 moles of what? Oxygen. If 5 moles of methane now come, it will combine with what? 10 moles of what? Oxygen. That one, you don't need any calculation to solve it. God bless you. God bless you. The correct answer is A. Wow. That's fine. That's fine. I think the answer is C. You tried, but it's not actually C. It's not C. You tried. The correct answer is A, as I've explained. That 1 mole of methane, I've showed you here. 1 mole of methane there. Here, you can see it here. That here is 1 mole, just 1 mole. Yeah. So 1 mole of methane joined with 2 moles of oxygen to give you the product. Now, if 2 moles of methane now come, it will not join with what? 4 moles of what? Oxygen. If 3 moles of methane come, times 2, they will be, if you are multiplying methane times 2, you also be multiplying oxygen times 2. If 3 moles of methane come, it will join with what? 2 times 3, that is 6 moles of what? Oxygen. If 4 moles of methane comes, it will join with what? 2, that is 2 times 4, that is 8 moles of what? Oxygen. If 5 moles of methane is there, it will bond with what? It will bond with 10 moles of what? Oxygen to bond completely. So you can see there. So the correct option there is option A. It's option A. So I hope you understand that. If you understand this particular question, drop it on the comment. If you don't understand, let me know in the comment. Now look at this question. Option, the question, the one at the top says, which of the following hydrocarbon burn in air with a sooty flame? Now, the reason why I want this class to be interactive is I want you to, yeah, you are correct, 10 moles of oxygen, you are right. I want us to make this class more interactive. That is why I'm throwing some questions. I'm throwing some questions for you to drop the answer in the comments. To drop the answer in the comments. To drop it. So now look at this question. Which of the following hydrocarbons burn in air with a sooty flame? Benzene. Burn in air with a sooty flame. The correct answer is benzene. But what is benzene? They don't tell you whether it's benzene or not. But you should know the formula of benzene. I've mentioned the formula of benzene several times. C6H6. And the question is, you can browse it. Why is it that benzene burn in air with a sooty flame? Why? Something's happening there. Is it the problem? Is it caused by carbon or by hydrogen? Why is it that benzene burn with a sooty flame? Thick sooty flame. Why? Tell me in the comment. Is the problem from carbon or from hydrogen? Tell me in the comment. Now, but I will explain this one now. This next one. Now look at this question. 2CXHY. If you are in this my group, you will see that I dropped this kind of question there. So see, we have that 2 at the front there is just like the mole. So we have CXHY. Now that CXHY, is what is there is just the combination of carbon and hydrogen, right? And carbon and hydrogen. Yes. We want to know what that that X and Y represent. It can be anything. It can be anything. That X now, if your X is 3, if your X is 3 and your X is 2, it can be 3, it can be 2, it can be any number. We don't know. You will remember that I told you earlier that I gave you a formula that you can use to balance. What is it called? Combustion. This is where we are going to apply the formula here. Yes, I can see a comment. So I think we should deal with them. Okay, especially because one of these hydrocarbon is not understand. Okay, one of these hydrocarbon I'm not understanding it. Which one? Drop it in the comment. Drop it now. The one you don't understand, I will break it down during this live video. Now, look at this. Now, let me now show you the formula you use to balance it. I showed the formula earlier, but I will still repeat it again. Now, look at this formula. Now, this is the formula we use to balance hydrocarbon. Especially students that found it difficult to balance. What is it called? To balance reaction. Yes. Now, I want to show you something here. Now, if you notice, this is the general formula. If alkane bond in here, this is the formula you use. If either petrol bond or anything, petrol, diesel, or kerosene, anything that bond or gas, this is the same formula you use to get to balance the reaction. So all these ones are just an example. Now look at it here. We have, what is it here? We have X here. Sorry, we have X and Y. Let me try to. Yes, you can see it here. We have X. Sorry, we have X there, and we also have Y. That X and Y, the represented values. X represents its own value, Y represents its own value. But how will you get it is that now, but look at something here. Look at something here. What is the mole of this formula? Whatever that is here must have a coefficient of 1. Nothing must be there. But if you look at that question, let me show you the question. If you look at the question, you notice that there is 2 there in front of let me show you. You notice that there is 2 here. There's 2 here. No, we will divide that 2. We divide all through by that 2, so that 2 can live there. Because if you look at the formula, the coefficient there is just only 1. The coefficient there is just only 1. If you look at the question, the coefficient. Now, sorry, if you look at the equation itself, now you can see the coefficient there is just only 1. Let me erase it so that you can see it. Yes, the coefficient from the formula is just only 1. So we need to divide that question. You can see the coefficient there. What is the coefficient there? It's just only 1. Now, but from this formula, let's try to understand something here before we. Now look at X here. We have X here, and we also have X here. Look at X here. So we will now go back to that question. When this one here represents hydrocarbon, it represented hydrocarbon, okay, burning with oxygen. You see all these ones here, they are just trying to explain it. I mean, they are just an equation to balance it. You don't really need them much. Now, this is just an equation to balance it. They are just an equation. All those X, Y, this one, they are just an equation. That's not where I'm going to. Now, if you see that we have X here from the reactant here, we have X. Now, but we have X here too. So any value that is here from that question, any value that is here, that is in front of this CO2 from the question, any value that is there, it will be the value of our X. It will be the value of our X. Now, let's look at the question. Let's look at the question. Now, look at the question here. We said this is X. This is X. So what is the value? What is here is also what? What is here is also X from the formula is X, right? So our X here now Our x here is what? Okay, no, that's not, it's not like that. I said something that you will divide by 2. You will divide by 2. Sorry, you will divide by 2 first. You know, if you divide both all of them by these 2, if you divide by these 2, here will be what? Here will be 11 over 2. Here will turn to what? 11 over 2. Here will be 8 over 2. 8 over 2. And 8 over 2 will give you 4. So what will be here? What will be here is what? Is 4. Is what? Is 4. Take note of that. What will be there is 4. And if you divide this place by 2, this 6 by 2, if you divide it by 2, you will have 3. So what will be there is 3, not 6. Take note of that. Now, after getting it, from the formula, you know, we said what is here? X is the same thing as the X here. So that is, you know, we have already divided this one by 2, which will be what? Which will be 4. Let me try to erase this so that you can see it. Which will be 4, right? So what will be here is 4. Take note, we have gotten the value of our X to be 4. What about the value of our Y? What about the value of our Y? You know, we have already divided this place by 2. We'll be left with what? We'll be left with 3, right? But from the formula, let's look at the formula. Let's look at the formula itself. You notice that from the formula here, we have our Y. We have our Y here divided by 2, telling us that the value of Y was divided by 2 here. But we don't want to divide by 2. That is, when you divide Y by 2, you know, from the question, you know, after we have divided by 2, here is what? Here is 6. This particular place is 6, right? I'm sorry, it was here is no longer 6, but it was what? It was 3, right? That is, if you divide Y, it will give us something like that. But okay, let's look at something. Let's look at something from the question. Let's look at this thing. I'm coming. Okay. Yeah, we are there. We are almost there. Yes, it's correct. So let's look at the, you know, yes, from the question. I mean, from the general formula we use. You know, here is what? Y over 2, right? And we are looking for Y, not Y over 2. If Y over 2, here is no longer 6, so I've explained earlier that you divide all of them by these 2. So here is 3. Take note. Believe that here is 3 now, not 6. So if you divide this 6 by 2, you have already, what you have here is what? Is 3 already. But are we looking for Y over 2? No, we are looking for Y itself. So what will you divide 2 with to give us 3? It's still 6, because if you divide 6 by 2, it will give you 3. So our Y there is 6. Is 6. So the name of this compound now is what? Is C4. We have gotten X to be 4, H6, and that is what? C4H6. What that is what? That is butyl. Option B is correct. That is butyl. No, someone say okay. Tell me what is going on. Why did he say Tell me, let me know. I will reply your this thing, your thought. Just drop your view here. Okay, drop it. I will reply you. Okay. Let's proceed. So that's for that. I asked you to drop something on the comment. That what make benzene to burn with a sooty flame? Is it caused by that carbon or hydrogen? Just give a brief explanation on the comments here. Brief explanation to that. So that's for that. Now looking at this is just like, now this is very, very important. This is very, very, very important. Very important. Take note of this thing. Now, if you look at this structure, in the next maybe 3 minutes we round up, or 4 minutes we round up. So if you look at this question, this is how we prepare it in the laboratory. Now, you may not see it clear, but let me explain to you. What is here is ethanol. ethanol, C2H5OH. That is the formula of ethanol. Now, if we are trying to get if we are trying to get ethene, if you are trying to get ethene from ethanol, let me just give you the summary of what is going on here. If I'm trying to explain everything, in time will not permit us. We are trying to produce ethene from ethanol. Now write this thing down. Now write it down as I'm telling you. C2H5OH. We want to get ethene from ethanol, and you know ethene is just only hydrocarbon. And the formula for ethene is what? C2H4. We want to produce ethene. The same way you produce ethene, you know ethene is under alkenes. So that is the same way you produce all other members of alkenes. The same way you produce any members in alkanes, that is the same way you produce all of them. So we want to produce ethene, and that is how we also that is the same. The method you use to produce ethene is the same method you use to produce all other members in alkenes family, because ethene is under alkenes family. Now we have C2H5OH. We want to subtract C2H4 from it, because that is the formula of ethene. What will you do? First of all, remove that OH at the back. Remove it. When you remove that OH at the back of ethanol, if you remove it, you'll be left with what? C2H5. But we are looking for C2H4. Okay? So if you remove one hydrogen from that 5, add it to that OH. That OH will become what? H2. That is, the hydrogen will be there too. H2O, right? Which is water. And you'll be left with what? C2H4. That is ethene. So what does H2SO4 there stand for? That concentrated tetra also sulfate 6 acid. What it stands for there is the function of that acid is to serve as a drying agent. That is, it also serve as catalyst to alter the rate of the reaction. You understand? So, do you understood what I just explained now? If you remove H2O from, first of all, remove that HOH at the back of that C2H5OH, which is ethanol. Remove that OH, you'll be left with C2H5. Then remove one hydrogen, add it to that water, and that HOH. It will become, that OH will become H2O. That is, the hydrogen will become 2, right? So you will now be left with what? C2H4. So at the product, you have C2H4 plus water. So that is for that. That is, you can see it here. You can see it here. We have ethene and water. So that is how ethene is being produced in the laboratory. But when I remove that H2O, what did I do there? Is it addition? Did I add anything? No. Option B is wrong. It's not addition. I didn't add anything. Substitution. C. Look at option C. Did I remove something and replace it with another thing? No. I only remove just H2O without replacing it with anything. I remove H2O. I'm left with C2H4. So I didn't replace it with anything. So option C is also wrong. Condensation down is automatically wrong. So what happens there is what? Is elimination. I eliminate. So I eliminated, what is it called? This I eliminate H2O from it. I remove it. I subtract it from it. So that's just it. So I'm seeing some questions. Let's I need to go. It's 11. Let's see by. What is this thing? So I don't understand. I will soon round up like this. So this place is, can you come again with the explanation? Which one? Which explanation? Is it the thing? So I repeat. Okay, let me do that in the next 1 minute. So I said, now you can see at your left hand side there, we have ethanol. We want to produce ethene from ethanol. Okay. So, and to do, you know the formula of ethanol. Ethanol is C2H5OH. Okay. So how will I going to produce ethene from C2H5OH? First of all, we want to remove that oxygen, because ethene is just only purely carbon and nitrogen. No oxygen. So first of all, remove that oxygen and that OH at the back. Remove it first. When you remove it, the one you are explaining now. Okay. So when you remove it now, when you remove that OH, you know, you'll be left with. That's why I'm telling you to Bring out your notebook, write all these things down. So when you remove that OH at the back of C2H5OH, if you remove that OH first, you'll be left with C2H5. Then remove one hydrogen from it. I'm just giving you the summary, because if I'm to explain this diagram, it will take several minutes. So if you now remove one hydrogen again from that 5 hydrogen left, add it to that OH. That OH will become H2O, right? That is water. And you will now have what? What will you have left? C2H4 is no longer H5, it will be H4. So that C2H4 is the formula of ethene. So that is how we prepare ethene in the laboratory. Okay? Now, this is a question I want to throw to you guys. What is the function of that caustic soda, that is sodium hydroxide? If you are preparing ethene, what is the function? They added sodium hydroxide there. You can see it. It was added here. You can see it here. It was added. So what is the function of that sodium? Okay, let me do it like this. The sodium hydroxide here is to remove impurities. Impurities, those impurities in ethene, to remove them. But now my question is, what are those impurities? Drop them in the comments. I want this to be interactive so that you will understand this deep. So what are those impurities? Drop them in the comments now. Drop them. Okay, so let's proceed. We're almost done. We're about to round up. So the correct answer to that is elimination, as I've explained. I think this is the last questions we'll be looking at for today. The polymerization product of ethine is what? Polymerization product of ethine. If you polymerize ethine, it will give you what? Now, ethine, what is the formula of ethine first? If you look at these options, these are the last questions. Take note, these are the last questions for today. So if you look at these options, you will see that they don't even tell you the name. They expect you to know their name. You understand? They expect you to know their name. If you look at option A, does it have double bond? It's just only single bond. That is cycloalkanes. If you look at option B, it's cycloalkanes. Option C is also cycloalkanes. But option D is benzene. Take note. Benzene always have double bond. It will be 3 inside the benzene structure. It must be 3. Let me show you something. It must be 3. Now, if you have the double bond there, they have it here already. You must leave this one. Don't put anything here. You don't put anything here. So you come back to the next one. Put here. Leave this one. Don't put anything. So come back to the next one. You can see it there as they put it inside there. So I'm just trying to show you. So that is benzene. That is benzene. Now, when you polymerize benzene, the formula of benzene is what? C2H4. When you polymerize the ethine, what will it give us? Ethine, the formula for ethine is C2H2. Now, if you bring, what is polymerization at first? Let's take note of what is polymerization. It's just bringing the combination of, different combination of monomers. For example, now you want to polymerize ethine. You will combine different monomers of ethynes. Combine them together. So if you combine 3 ethynes together, it will give you what? I said ethyne has a formula of what? C2H2. Now let's assume you bring another C2H2, join with it. It will give you what? C4H4. And the formula of benzene to be C6H6, right? So if you now bring another compound, another monomer of ethine, that is another C2H2, join with that C4H4, it will give you what? C6H6, and that is what? Benzene. So they represented in structure. These are exam questions. So the correct answer is option D. Wow, God bless you. This person is trying. Yeah, it's correct. It's option D. Yeah, so we have come to the end of today's class. If you have any questions, you can always drop it on the comment here. Okay, you can drop it on the comment. So I would like you to subscribe, share with your friends. Come back. This live section video will continue, although we make it better than this. Okay, we make it better than this. So try to share with your friends. Like the video, share with your friends. You can still watch it over and over till you have the full detailed explanation about on this same thing. So if you have any question, you can always reach out to me, drop it in the comment. I will definitely reply. So thank you very much for your time. I appreciate every one of you participated in this class. Like this guy, I appreciate you. Yeah, I thank you all for your time. So see you in my next video. Thank you. God bless you.